Okay guys, so today, so now we have to understand mechanical energy. Okay, so mechanical energy means kinetic energy plus potential energy. We call it gravitational potential energy. Kinetic energy is given by half into mv square. Gravitational potential energy is given by mgh. So this is what we are going to discuss now. So case 1, only kinetic energy. EK means kinetic energy. Kinetic energy. Now, suppose this is your ground. So, MA mass is moving with U1 velocity and MB mass moving with UB velocity. So, I would say UA velocity and UB velocity. Right? Now, so, and this U velocity is a constant velocity. This UB is also constant. Okay. UA also constant, UB also constant. Now, the kinetic energy of this one, I would say kinetic energy of object A is going to be half into MA UA square. Kinetic energy of this one, EK P would be half into MV UB squared. Right? Now what we have to understand here is this is my ground. This is my ground. From the ground, is there any elevation to the object? No. So that means from ground to this object, height is 0. Height is 0. Right? So in case 1, only EK, kinetic energy. So H is equal to 0 in that case, right? So now when you have EK only, there is a motion, right? So motion exists. Because it's moving, right? Then only you get the kinetic energy. Right? So now let's move into our case 2. Let's move into our case 2. In case 2, only EP, or some people write EG. This is gravitational potential. Gravitational potential. So in that case, your ground is here. Suppose you have a ball here, M ball. This distance is H0, right? Then you are going to lift that ball here. Then that distance is going to be H, whatever, H1. Then there is another one here. So that would be H2, right? Now this is A situation, B situation, C situation, right? So now, do you have a motion here? No motion. No motion, right? They are like stationary at that situation, right? So, but here you have G, right? So, however, due to this height, this object, the same object, has E potential at place A, which is mgh, which is h is 0, 0. For this guy, E potential at B, which has mgh2. This guy has EPC, which is h2, the other one is h1. So it is like that. So obviously this is greater than this and this is greater than that, right? So now we have to understand, the first one, kinetic energy, is in presence of the motion. Second one is in absence of the motion, but the height is changing, right? Yeah. Now we'll understand this. Okay. Question. Consider a vertical motion. Means you are going to throw a ball up. When you throw a ball, what will happen? You are throwing from here. So this one has velocity here, u. Now it's moving, right? Then when it comes here, its velocity is v, still m, and this height is h1. When it comes to here, you will see that the velocity becomes 0. This height becomes h2. Right? So this height becomes h2. Now if you look into this guy here, right? Now that guy has a position dependency as well as that guy has a velocity, motion, right? Motion plus position dependency. Now when you go back to here, this is due to position dependency. No motion for these situations, right? You just keep the ball here, that's it. Ball is not moving. This is motion dependent. This is position dependent. This is both dependent, right? So if you look at this, suppose this one is A position, B position and C position. So if you want to find EA, that would be E of kinetic at A plus E of potential at A. So E kinetic at A is half into mu square, potential is 0. Why h is equal to 0? Now if you look into this, EA is equal to half into m v square plus mg h1. If you look into this, EB, right? This is EC is equal to half into m, again 0, plus mg h2. So it's going to be mg h2. So now if you look into this, you will see that mg h2, this one and this one, right? So okay. Again, you see here, can you see if you look at this EKA, this one and this one, so that means this, they are different. Kinetic energies are different, can you see that? Yeah. Also, can you see that this to this is different? So that means potential energies are different, kinetic energy is also different, right? What about the total energy? What about the total energy? These are different, that's fine. These are different, that's fine. But what about the total energy? This is total energy at C, this is total energy at B, this is total energy at A. What about the total energies? That means addition, right? This to the total energy, the green color part. What do you think about that? They should be equal to each other. Individual parts are not going to be equal, but the total energy, once after you add it, they should be equal to each other. Why? They convert. That means we use energy conservation. Due to energy conservation. Now here what you have is mechanical energy. What is mechanical energy? Mechanical energy means both kinetic energy plus potential energy. Those two are called mechanical energy, right? You can have another energy, like for example, say when you are having this, you have kinetic energy, potential energy, you have some other energy. Now we can define another energy, we will define it later. There is another energy added to this system in the future, which is spring energy. Spring. We have, it's a common question in the test, you have a spring, so spring is doing this motion. When the spring is doing this motion, you can see, yeah, obviously it is changing, velocity is changing. Obviously you can see when it is going up, down, up, down, up, down, position also changing. Then you can see this kinetic energy is there, position dependent potential is there. On top of that, this object is going up, down, up, down, up, down, but it is attached to a spring, right? So spring is stretching, compressing, stretching and compressing, right? So there is a spring energy as well, because when the spring is doing compression and expansion, there will be another energy part involving, which is called spring energy, right? So there will be another spring energy part added to that one later on. Now in the exam you will get spring type questions as well as just these kind of questions. So two types of questions are going to be there in the exam. So that means from this lesson, this is a little broad lesson. So from this lesson, few questions are there in the exam, targeting few areas of this big lesson. Okay. So that is happening. So due to energy conservation, okay. Due to energy conservation, right? Due to energy conservation, total energy at A should be is equal to total energy at B is equal to total energy at C. So that means you can say half into mu square is equal to half into mv square plus mgh1 is equal to mgh2. right? All good? Now, what is the unit of energy? What is the unit of energy? Joule. Joule, right? Joule. So, what is energy per unit time? Because this power. Because this power. That means energy per unit time means energy divided by time. This is called power. Energy is joule. This is second. So this will be joule per second. Joule per second. Joule per second is nothing but 1 joule per second is 1 watt. 1 watt. So power is measured by watt. Watt. What is a scientist? Joule is a scientist. Coulomb is a scientist. Newton is a scientist. Planck is a scientist. So we have in the future Planck constant. Scientist. Coulomb force. We have it in the future. Scientists. All are humans. Now, if you think about the power, now when you in the winter season you go to Bunnings, and then you need a heater, whatever, oil heater or whatever, then you mainly look at what is the power. Is it 5,000, 2,500, 3,000 or 1,000? So if your room is so small, you are going to buy maybe 2,000 watt. Now if you look into the thing, you will see that 2,000 watt W. That what means power they are mentioning. Power means joule per second, right? So 2,000 watt means that heater consume 2,000 joules per second. Huge, right? Huge. That's why if your room is so small, you are not going to buy 5,000 watt thing, right? Because in 1 second 5,000 joule is gone, so your electric bill is gone, right? So that is what understand. Now this is all about joules. Now joule is a measure to the energy. Now that's fine. Is it a scalar or a vector? Is it a scalar or a vector?
Watts?
No, joule. The energy. Energy is a scalar or a vector? Energy, sometimes people call work done. Energy or work done. This is a scalar. Scalar means no direction. It's just a value. Now there is a heater, we call it 2000 joule. I mean, there is no direction, right? It's just a value 2000, right? It's a scalar. Okay. Now, think about this question now. Think about this question. You have a projectile motion, right? You have a projectile motion here. This is u. This is theta. Right. So, okay. this is h. So this is a point here, b point here, c point here. I'm not going to ask find HO, find horizontal distance r. This is not what I'm saying. This is not what I'm saying. So in a question, they might ask find maximum height, find r, all those things. After, they might ask you find the mechanical energies. Find the mechanical energies at points A, B, C. Okay, do that quickly. Okay, so EA is, what is the kinetic energy? Half into m u square. Okay, this mass is m. Okay. Plus ground is this, right? So ground means you measure the height from the ground, so it's going to be 0. So EB velocity is 0, right? mgh. EC velocity is again half into mu square. Why? Because of the symmetry. Because this is coming with the same velocity u. No air resistance, nothing. Due to symmetry, if this velocity is u, it should reach by u, because you can see the symmetry this side and that side. No air resistance, nothing. Under that condition, that happens. Kinetic energy is 0. Any comments? You forgot something. At the highest point, the vertical velocity only 0. But there is a horizontal velocity which is u cos theta. Now, answer is there to your question. There is a gravitational pull, that's fine, but it is not straight away pulling down. There is a velocity, it gives a motion to break that situation. So, u cos theta. So, this should be EB half into m u cos theta, the whole thing is squared, plus mgh. That's the right thing. Any questions? Think about this. Think about this. Now, case 1. If you touch the depth of the matter, that means it's a big result. If you okay, not me, I try my best. This is u, this is u. Then according to this, at point A, E kinetic at A would be half into m squared. Correct. Right? Now what I'm going to do, case 2. Case 2, I'm going to resolve it. Resolving means what? Resolving means you replace u by the vertical and the horizontal. This is going to be u cos theta. This is going to be u sin theta. Makes sense? Then what about, this is A again, right? So what about EK AD? Half into, this is mass m, right? Mass m. Half into m. Now I'm going to use the vertical velocity here, which is u squared sin squared theta. Plus, I have to consider the horizontal as well, right? Half into m u squared. I'm bringing you to different level in our understanding. So, Now you can factorize. So when you factorize, you get sin square theta plus cos square theta. Right? What is sin square theta plus cos square theta? So now look at case number 1 and look at case number 2. In case number 1, I used the original u given in the system. Then I get the value half into mu squared, right? Case number 2, I resolve that u into pieces. Then I consider those resolved velocities to calculate the kinetic energy. Right? So, but I got the same answer. Yeah. So what is the conclusion? What is the conclusion? It doesn't matter. Conclusion is it doesn't matter. You take the resolved velocity components and find the kinetic energy, or use the original one. It doesn't matter. Now, if you resolve it and find, still you get half of mu squared actually. That proof is not there in any book, right? But exam people are very constructive. When you do past papers, we will see in any subject, you will see they are very much constructive. So they try to, use these kind of stuff, because this is not knowledge, right? This is some common sense connecting the things what you know, right? So they now target those kind of things. So think as much as you can when you go home. Just have that in your mind. Okay. Next question. Suppose there is a path like this. Suppose there is a path like that. This is N pole going horizontal with you. This is your ground. This height would be h. So this slides on this ground, on this path, and then this is d. The question is, if u is equal to 10 ms minus 1, h is equal to 5 meters, m is equal to 2 kilogram, find the value. This is point A, this is point B. So E mechanical energy at A would be equal to half into mu squared plus mgh. E mechanical energy at B is equal to half into mv squared plus 0. Right? So using energy conservation, these things you have to write, because this is exact. You have to write what law you are using. It's not just bunch of values there. Some people do it like you get you think you get 50, you get 30. Why? Because I have seen students like that. I'll tell you one example later. This M m of that's it. So now you get half u square plus gh is equal to v square half u square. So now what you can do, u is equal to what now? 10. So it's going to be 100 divided by 2 plus g is usually taken as 10, 9.8, 10. H is 5 multiplied by 2, it's going to be v square. So it's going to be 50 plus 50, 100, 100 times 2 is 200. So v would be 10 square. That's how you do that. Consider this. M1 has U1 is equal to 10 ms minus 1, U2 0. Then they collide. It's in the same line. It's in the same line. They collide. Then they don't stick. This one goes to. Actually, this one goes to this side. With V1 is equal to 5 ms minus 1. M2 after collision, right? M2 goes to the right hand side, which has V2 velocity, right? So this is before collision. This is after collision. First question is find V2 velocity. Second one. Is there any energy loss during collision? Is there any energy loss during collision? That's the question. So now you can see it's a collision, right? Before situation, after situation is there. And you can see it's a linear motion. All are on a horizontal line, yeah? Then this will tell you that you can use linear momentum conservation. Yeah. So using linear momentum conservation, that means P final is equal to P initial. Now the first one is M1 U1 plus M2 U2, and then M1 V1 but minus plus M2 V2. Why minus? Because this one is that one is opposite. The rest of the stuff are in the same direction. Okay? So from here, M1 is how much? M1 is not here, right? Something is equal to M2 is equal to 1. So you can have 1 times U1. How much is U1? 10 plus 0 is equal to minus 1 times 5 plus 1 times 2. So we will get 10 is equal to minus 5 plus V2. So V2 should be 15. So we can calculate that this V2 is 15 in the right side direction. So why it is right side direction? How do you conclude? Well, because math tells you it's plus. Because we use that equation we consider flux to be in the right side. Okay. So now energy loss, right? So energy loss we part. Energy loss would be energy before minus energy after. So energy before would be definitely it's kinetic energy, no potential, right? But because it's horizontal line, it's not jumping up, right? So it's going to be half into m1 u1 square plus half into m2 u2 square minus, this is before, after half into m1 v1 square plus half into m2 v2 square. So it's going to be u1 is given I think 10, right? So it's going to be 1 times 100. This is 0 minus half times 1 times v1 is 5. It's going to be 5 squared, right? The other one is 15, right? So plus half into 1 times 15 squared root of 5. So what number is it? 50, right? Minus 12.5 plus 100 something. So now this is a negative one. Negative value. Right? So what is the conclusion here? Energy loss is a negative number. If energy loss is a negative number, what do you mean by that? Huh? Yeah, energy loss positive means there is energy loss. Energy loss negative means what?
Energy gain.
Energy gain. So how come a collision gives you energy? Automatically energy is gained, like, right? So this is not possible, right? So energy gain. So not possible. So what is the problem there? What is the problem? Energy gain cannot happen. Our math, everything is fine. Methodology, theory, everything is fine. So what's the problem?
Is the question also correct?
Question is not possible. Why? Because now these two are fine, they are going this way. Now after collision, this will never reverse it. After a collision, that will never reverse it. So it might go that direction. So the question is itself, the construction is not possible, not practical, so that when we use the concepts, they are not working properly. Okay. So because we are dealing with physical situations here, right? So if there is a theoretically, mathematically, you can create situations, right? You can make heaven theoretically. But if the heaven is not existing, what to do?
You said this was an exam question. Was this an exam question?
Exam type question.
Okay.
But in the exam, it might be like this. I showed you some questions like that, right, last week? I gave you a tutorial, right, last week? That's what we discussed. Print out I gave. I don't know. And I discussed few of the questions, right? So otherwise there should be a collision, but according to the situation given, we don't have. Now, this summary is important. Energy or work done, right? So energy or work done we calculated by using motion. Okay, half into use energy work done we calculated due to motion. Energy or work done we calculated due to position. That would be mgh. Right? These two combinedly, this is ultimate summary, these two combinedly we call mechanical energy. These two combinedly we call mechanical energy. Right? Then there is another way to define your work done. There are only three things in physics. You can define work done, and if you know that as a fact, then you know how to construct when you get a question, how to think. Right? So when motion stuff, position stuff are available, you work with mechanical energy. This one is using force. Using force. Now, that is obvious that you have seen if you push something, that moves, right? That moves means there is a motion. That means that motion is coming due to the push, the force. So that force is involving towards this energy creation, right? Yeah. Into energy creation. Any questions? Right? Okay. Now understand carefully. The work done or energy is defined by using forces. This work done is force times distance. So that means force times distance is given by d. So the unit wise force is Newton, d meters. So that would be Newton meter, and then work done is measured by Newton meter as well, right? So the work done or energy is measured by joule as well as Newton meter. So we know that 1 Newton meter is equal to 1 joule, right? 1 Newton meter is 1 joule. 1 joule is equal to 1. Right. Now, there is another connection. So these are the three things you have to know. But there is another connection that we can come up with. Now, we are talking about energy, right? We are talking about work done. So we have three cases that we can talk about the work done. Then we, in three different ways, we are discussing this work done, right? Same work done we discuss in three different ways, right? But we are talking about the same work done in three different ways, right? So then there should be an interconnectivity between those three things, right? So it's like I love my mom, my brother loves my mom, my sister loves my mom. So there should be interconnectivity between these three. So we are brothers and sisters. So likewise, the interconnectivity between these three would be, there should be interconnectivity here. Interconnectivity. And that interconnectivity I will teach you.